Okay, everyone, we'll get started again. Thank you for filing in. I know there's some people in the foyer I see filing in as well. So let's start this next session with a presentation by Hajo Eicken entitled Tracking Changing Arctic Seas for the Benefit of Planning and Operations. As many of you know, Hajo is the director of the International Arctic Research Center at UAF, the University of Alaska Fairbanks, America's Arctic University. He's also a professor of geophysics, and his research includes studies of the growth, evolution, and properties of sea ice in the Arctic and the Antarctic. Hajo, welcome to the podium.
Thank you. I appreciate the opportunity to take this slot here and speak to you about something that I certainly care deeply about, but I know a lot of other people do as well. But while we're getting settled, I was just reflecting on Zach Hamilla's comments during the previous presentation with people associating Canada with the Arctic. So I'd like you to imagine something in terms of neighboring countries. Imagine we had a neighboring country twice our size, for a long time been one of our staunch allies. We have excellent trade agreements with them. You know, they basically provide us with a lot of goods and services for free and have for a long time. And now we're seeing a regime change underway. It looks like this country is turning into an irrational actor. It has the ability to threaten our energy security, disrupt trade patterns, potentially affect how people think about the country itself and global politics and stability. You want to know what the heck is going on in that country. And I would argue that we don't really, because that country isn't North Korea, that they're not twice our size. It's the Arctic Ocean. Arctic Ocean is undergoing a significant regime change. I don't think we quite know yet where that's going to end up, but it's clear, and that's one of the reasons why we're here, that that will have significant implications for a lot of things that a lot of us care about deeply. So what I was thinking of doing is, and I didn't take the 1 hour, even not having taken the 1 hour instructional video for the remote, I was going to try to set it up in terms of the Arctic as a provider, and we have a lot of indigenous people from the Arctic here. The Inupiat, the Yupik people, of course, have lived with the Arctic for millennia. The Arctic as a provider, but even your provider is not always gentle and kind, and you know and learn how to live with that. That is a very long history of thinking about the Arctic, and implicitly, we've been thinking from a Western perspective about the Arctic as a provider as well. We haven't really, I would argue, framed it in the right way, but we certainly have benefited from the Arctic in a number of ways, and I want to briefly illustrate that here in a moment. But now increasingly we're hearing and seeing talk about the Arctic as a disruptor, and that's something I'd like to reflect on as well, because either way, I mean, and I'm not saying it's an either-or thing. Of course, this is a false dichotomy in some respects, but no matter how you think about the Arctic, including in terms of this rogue actor metaphor I was alluding to earlier, the one thing you need and you want intelligence about what's going on with that neighboring area that's twice our size and has the ability to significantly disrupt or benefit whatever it is we do for a living. And that requires observations. It requires a range of different approaches to learning more about how does the system work. And I'd like to spend this talk just briefly giving you 3 perspectives on how do we observe a changing Arctic? What are some of the challenges that we face in doing that? What are potential benefits of doing this well in the context of planning for Arctic futures and present day or future operations? So I was going to briefly talk about just observing frameworks more broadly, give you a bit of a flavor of what's happening at the national, international level in terms of sustained observations. I'll then focus a bit more on what are we seeing in the Arctic Ocean, and not the usual stuff. I mean, you probably see satellite imagery of receding sea ice every other day. So I was going to try and go a bit deeper than that, and I'll try to illustrate how some of these things may have an impact down the line. And then I'll focus in the third part of the talk on just what are we doing, what can we do in coastal regions in particular, in Alaska and Arctic Alaska, where there's already significant change underway, and that type of effective response requires new types of partnerships and collaborations that I'll be talking about a bit here. So let's start. If you think about the Arctic as a provider, it's important to recognize, and several people have pointed this out earlier. Senator Murkowski mentioned, the Arctic in the context of climate stabilization. So you can think about the Arctic providing important services and benefits. And I've highlighted a few here. If you just list them, that's a trivial exercise, but it is important to point out that the Arctic is an important climate regulator on the global scale. Of course, a lot of people in the audience here, I'm sure, have hunted out on sea ice and know a lot more, certainly, than I do about the importance of Arctic processes in the context of marine food webs. You've just heard earlier from Peter Harrison about the broader picture, international fisheries agreements or the Central Arctic Ocean Agreement. So there's different ways to think about the Arctic as providing benefits and services. In the context of observing system design, it's taken us a while to really, at least from the research perspective, to translate those broad benefits into very specific action as to what exactly are we going to observe, how, where, and for how long. And I'd just like to give you a glimpse of what's currently slowly gaining momentum within the Arctic research community. It's something that the global ocean observing community has been doing for a while, for about close to a decade, and that is to come up with frameworks for observations that link the societal benefits that we can derive from observations. Some of them you can measure in economic terms. The European Union just published in October last year a report on the economic benefits of sustained Arctic observations. That's the IMOBAR report. The Science and Technology Policy Institute here basically led the charge in 2017. In January, there was a workshop here to look more specifically at what they term a value tree analysis. And those types of approaches are catching on. I know that Japan, and we'll hear more on this later on from Atsushi Tsunami and others, is actually commissioning STPI or STIPI to work with them on how observations benefit Japan's Arctic policy. So these types of frameworks are great, but they tend to be fairly vague. And what we're trying to do now is take the next step and relate these broad applications or missions, whatever you want to call them, to very specific observations that need to be done. The example that you see here is for different types of sea ice activities, and I'll actually cover a bit of this during the last part of the talk to illustrate how you actually arrive at an observing program by going through these steps that take you from the broadly defined societal benefits all the way down to very specific observing networks or data networks. The challenge, though, is, and this is important, and something that gets back to this whole issue of what's environmental intelligence, and that is that there's a clearly recognized need to track climate variables. People are doing that. We have a satellite observing system that's doing a reasonably good job, increasingly better, in tracking a whole number of them, but not all. We're definitely in need of tracking variables or aspects of the Arctic that are relevant for decision makers and planners. We're not nearly as good at that for a number of reasons, and we can talk about that. And what we have essentially is a whole bunch, I'd argue a patchwork of different types of approaches of getting this information. These are individual projects that are springing up right and left. And it was interesting yesterday, Senator Murkowski pointed out, well, if you deal with health, you have the National Institutes of Health. And if there's a health concern, whether it's cancer, heart attack, respiratory problems, what have you, there are these centers that provide a unified approach at dealing with these types of problems. We don't have that in the Arctic. It's a very challenging issue. On the observing side, what's currently underway, which is an exciting effort, and again, I would argue that it's gaining momentum both nationally and internationally, is to accept the fact that we will never have a single blueprint-designed the Arctic observing system. We just won't get that, and we don't want it, frankly. What we want is, and what needs to be done is to take these little pieces and see how do you link them up to create something that provides you with shared benefits. And shared benefits, again, is an important aspect of thinking about the Arctic, including in a geopolitical context. Well, how do we get there? We have the Arctic Councils and the International Arctic Science Committee's SAON, Sustaining Arctic Observing Networks Initiative. That's a body that includes both Arctic and non-Arctic nations. It works well. It took a while to get this going. It's been in existence for over a decade, but I think now they're gaining traction. Iceland is doing a lot as the current chair of the Arctic Council to help move this forward. And feeding into that, we have US AON, the US Arctic Observing Network, an interagency alliance, if you will. Sandy Starkweather with NOAA is the executive director. That group is really helping move things forward. And we have, through IARPC and the IARPC collaboration teams, Interagency Arctic Research Policy Committee's collaboration team, a mechanism to actually get stuff done on this. At the international level, the Arctic Observing Summit is evolving into a forum for bottom-up planning that involves everybody who's interested in observations and involved in making them or using data from observing systems. And then we have other fora, and we'll probably hear more from Tsunami later this afternoon, such as the Arctic Science Ministerial and other processes that may help move these things forward. So in general, things are actually looking up. But of course, all of this requires resources. That's a big challenge. So I want to focus now on a few aspects of Arctic ocean change and illustrate where it is that we're lacking and where we might need to have to focus some of our attention. So you've all seen these types of plots here. This is a plot of the decadal scale trend in Arctic sea ice concentration during the time of sea ice summer minimum in September. You see these areas here that have been seeing losses of ice at the end of summer on the order of 10 to 20% per decade. So that's what, say, the Coast Guard might refer to if they're talking about, hey, there's a whole new ocean out there. All of this is reasonably well tracked, has important impacts, of course, in particular in Alaska, because the rapidity of the change does change coastal systems in a significant way. And that's something that's important to keep an eye on. What hasn't been covered as much that I want to spend just a bit of time on showing you, and I understand some of the details may not be of interest for everybody in the audience, but basically the next 3-4 slides basically tell you a story or hint at a story that's just emerging, and that is that while we think about Arctic summer sea ice loss, or the broader public might think about Arctic summer sea ice loss in more detailed terms, the important thing to be understanding of and anticipate is, are we about to lose significant parts of the Arctic winter sea ice cover? And so there's an intriguing effort that's underway by the International Arctic Research Center, which I had. Igor Polyakov is leading this, an international program, Nansen-Amundsen Basin Observing System, or NABOS. This group, a number of countries, key of this effort is a US-Russian collaboration, has been deploying instruments out here across the Eurasian Arctic for 15 years now, roughly. And what they're finding is something that's important, and I just want to illustrate that here. What you see here is a timeline from different years, 2004 here, 2009, 2010, 2014, 2015. What's plotted here is the depth at which the cold, fresh Arctic Ocean water of the surface is separated from the warm, saline Atlantic water sitting deeper at the bottom. Now, that Atlantic water has a lot of heat in it. It could, if you were to bring warm water up to the surface, you could melt the Arctic sea ice cover several times over. And in the geological past, there's been episodes where these types of processes have basically led to large-scale reductions in Arctic sea ice cover a long, long time ago. The common wisdom in the early 2000s was, well, because there's such a strong salinity and density gradient, that heat is never going to make it up. It sits down there, and that's what this plot shows here. The boundary is somewhere at 150 meters depth, 500 feet depth, way, way down in the ocean. We're dealing with the cold, fresh, ice-covered Arctic Ocean at the top. But what Igor Polyakov and his team have found over the past few years is that layer has been starting to move up In 2014, 2015, it had come up to 80 meters. The most recent set of observations they've recovered showed it's up even higher for extended periods of time, and that has major implications that I just want to briefly highlight here. Here's a sort of a schematic. I'd encourage you, a couple of years ago, that team published a paper in Science on what they call the Atlantification of the Arctic Ocean, where essentially what you see is that starting in the early 2000s, you have Atlantic water penetrating into the inner parts of the Arctic Ocean, enhancing heat exchange with that warm Atlantic layer and the cold surface layer, but also changing a lot of other stuff. And again, I just want to give you a brief glimpse of what that other stuff is. Why is that important? These types of changes in the Arctic Ocean carry with them significant risks. Loss of winter sea ice, for a number of reasons, is likely to result in significant changes in Northern Hemisphere precipitation weather patterns, impacts permafrost thaw along the coastal regions, land cover. Of course, important for maritime activities, but it's also important from the perspective of food webs. And I just want to give you a brief illustration of what this means. What you see here, these panels are basically, each panel represents a year in the currents, the way the waters flow and shear in the upper 50 meters or so, 150 feet of the Arctic Ocean, 2004, 2005, and then going up in time all the way up to 2014, 2015. All that you need to care about is that the Arctic Ocean of the early 2000s was a calm, well-behaved water body, well understood by ocean physicists, climate modelers, what have you. The most recent years, we've seen, or Igor and his team have seen an increase by a factor of 3 to 4 in the strength of these currents and the shear associated with these currents. What does that mean? It changes a whole bunch of things. From the perspective of Arctic operations, it changes the acoustic environment of the Arctic Ocean in a major way. From the perspective of heat flux, it brings heat up to the surface. From the perspective of points that Peter Harrison was getting at in terms of marine ecosystems, this year, and that's only now starting to emerge with the most recent set of mooring recoveries, it also changes the amount of nutrients that get up into the upper ocean, and so it has the potential to change Arctic food webs in the interior Arctic in a major way. We're starting to see the first signs of that, and what's important to keep in mind is that from a modeling perspective, if you look at large-scale models, the types of models that informed the Central Arctic Ocean Agreement, they haven't caught up yet because the physics behind these processes is not all that well understood in terms of putting it into say, biogeochemical models. So this is a model here by Doug Slagstad from Norway, gives you gross primer production over the Arctic Ocean, just to orient yourselves. So Ukravik is up here, Greenland, Svalbard, Eurasian Arctic. Essentially, what these models currently still show is an interior Arctic Ocean that over the course of the century, going from 2010 here into the mid-century towards the end of the century, is not a very productive area. And so that's been informing some of the fisheries conversations in terms of, well, hey, even if you have lots of Arctic cod up there, there's not a lot of primer production that actually sustains the ecosystem. That picture here, these new types of observations are showing needs to change because it does not reflect what we're seeing in reality. So that's an important point to keep in mind and was an important aspect, I think, or added urgency to the CAO agreement that you just heard about. So what do you do about this? So that's one key conclusion. These parts of the Arctic Ocean still are quite remote. They're difficult to operate in. Yesterday you heard how difficult it is for us to get even just one new icebreaker online. Icebreakers are important tools, but in some ways I would argue they may be increasingly irrelevant with respect to Arctic observing because we're seeing a revolution at lower latitudes of autonomous observing systems. A lot of the challenges that we have in the Arctic in applying that can be tackled, and there's momentum growing. I just like to illustrate this here with one example. This is part of a proposal that a larger consortium between a number of universities here put in to develop a center that focuses on the science and technology of autonomous observations of Arctic marine environments. There's a lot that we see that might be doable here in the future. So then just to give you a sort of more of a glimpse of what does this all mean in coastal regions, just a few slides on that. In coastal regions, the key point, of course, is that you have a range of different activities underway. You have coastal communities, you have industry using the coastal ice cover, again, as a provider. In Alaska, the resource industry probably derives value on the order of $100, $200 million every year by being able to put in ice roads on coastal sea ice and other forms of ice, and not having to provide for gravel roads and other types of infrastructure. So it's these types of activities that need to inform the types of observations you make. I'd just like to highlight an example that has been led out of the University of Alaska Fairbanks, the Utqiagvik or Point Barrow Sea Ice Observatory combines a range of different sensor systems. There's a coastal radar that's part of it, but most important, this is a collaboration with a number of people, Inupiaq ice experts in the community who provide observations and share knowledge and daily logs of their use of the sea ice cover, sea ice hazards, what have you. I see this AOK, Alaska Arctic Observatory Knowledge Hub, led by Donner Hauser and others, and a steering group from a range of coastal Alaska Arctic communities. To me, this is a good example of co-production of knowledge, where you're trying to take the best that technology has to offer, which people in these coastal communities already use on a regular basis, with indigenous knowledge, traditional knowledge, and to some extent local knowledge, and make something more out of it. And that more then allows you to look more closely at, for example, interpretation of the mean ice velocity field, or the speed at which ice moves along the shoreline. There's just an example here. If you want to apply this, you could do the type of thing that Nathan Kettle, who's part of a project that's funded through the DHS ADAC Center, and we've got Church Key here who's going to talk more about that. So this here is an example of how the radar system, drawing a range of different approaches, interviews with local ice users, hunters, and other operators in the area, how the team with Nathan Kettle, Andy Mahoney, and a couple of others has basically developed an automated tracking and hazard warning system where you can communicate the type of information you're deriving from the sea ice cover. There's a breakout event here through specific hazard notifications that go out to different bodies who have an interest in this type of information. So working more closely with the responder community, with long-range planners, with people who have indigenous knowledge and are familiar with the region is a key aspect of the types of approaches that we're needing in the future. And I'd like to close by just emphasizing again, I started out with this metaphor of the Arctic as a disruptor, and termed it in terms of a rogue nation. I think it's important for us to recognize that Arctic and non-Arctic countries are threatened by a changing Arctic that is not fully understood, that has significant impacts on operations at lower latitudes. It's that fact, the fact that extreme weather in Eastern Asia, Japan, South Korea, China, can be directly linked to anomalies in sea ice extent in the Arctic, that motivates a lot of non-Arctic countries to be part of these conversations. And it's important for us to recognize that in the Arctic, currently it is universally understood that all of this information has to be collected collaboratively and in a congenial fashion that recognizes shared benefits of the observations. And it's useful to keep that in mind. Thank you.
Thank you. Thank you very much, Hajo. Outstanding presentation. I wish we had more time for it, but appreciated the scientific components, the modeling, the future looks, but also from the local to the more broader international perspectives as well. So thank you very much.